So each of the ones knows which one is carrying the truth at any moment. Interfaces from the baggage handling system. The one main obvious one is power. Power comes from the base building. So it comes from outside the building first, through base building systems, CDPs, and switchgear. It's often monitored or backed up by local generators or UPSs or other systems. It feeds down to motor control panels, and once it enters that, it becomes the baggage handling vendor's responsibility. In there, they monitor the presence of incoming power and further distribute power to downstream conveyors. The base building services monitor power use at the CDP level and also should look for power quality monitoring. One of the key things we found is harmonics being a main problem in terminals. Baggage handling systems contain VFDs, and those impart harmonics on the line. In addition, other things that aren't related to baggage at all, such as LED lighting, can do that, and that can cause unintended interference, either on baggage systems or on other things. Also, wear and tear on different equipment has been seen with those harmonics. Once the building goes into generator mode, a lot of subsystems need to know this, baggage handling being one of them. So the generators will send signals to the building management system, and so will the fire alarm system. That might go to BMS, or you might have relays directly to the baggage handling PLCs. The BMS or the fire alarm system will then send that info to the PLCs, which can then react accordingly. You could theoretically just hit the power on the baggage system and turn everything off automatically, but it's often better to control things, leave things under control so that they can be shut down safely in a controlled fashion, or to maximize safety, such as at fire doors. In the case of a smoke event in the building, baggage handling fire doors, often you'd want to flush the conveyor underneath and then start closing the door under control. An older way of doing this would be to have a relay at each fire door, but then the fire door itself will just be forced closed. And if there's something underneath, it'll get squished and the door won't close on its own. Nowadays, we like to put those signals to the PLC, and then the PLC knows to flush the system. If the door closes onto a bag, the PLC can then open the door again, allow the bag to go through, and close the door on its own. The failsafe to this is a fusible link at these doors. If there is a fire locally to it, the fusible link melts and the door falls shut. Commissioning of this is a bit integrated in that the baggage handling system has to close under control in many ways. But often the authority having jurisdiction also will want to see bag doors close on fire alarms. This will be done with smoke alarm zone tests, sometimes using the smoke alarms at each door, or incrementally going through each of the fire and smoke zones in the building and ensuring the correct conveyor doors close. Also, you'll do a drop test where you pull a lever or otherwise activate or simulate activating the fusible link so that you can see that the doors fall shut on their own. Next, we'll look at the information network. The baggage handling PLCs are often in redundant mode. There'll be hot backups. So each one is containing all of the information at once. In case of failure of one, the other one automatically picks up. There's devices in the field, specialized subsystems such as automatic tag readers, that talk to those PLCs on the control network. Those will also be redundant to each of the two. Some of these systems also talk up to other reporting systems. So they will also have base building data connections to them. Each of the PLCs will also need base building data connections to switches that are out there. Parent from the switches, again, you'll get connections to the data centers, servers, and other workstations that are out in the field. The base building network team needs to create VLANs for the baggage handling system, and the airport operations database, and various other systems that might be there, and depending on how they want to segregate network traffic. Before going on to commissioning, all of the base building network needs to be operational so that the servers can be in their final location and that all of the networking can work correctly. In addition, there'll be remote access for airport operations people, controls engineers, and even airlines for porting access. This is all important to have before the main commissioning phase starts. In most new construction, this means that there needs to be a priority for building of data centers and communications rooms out in the field. In commissioning this, there's also integrated work that goes not just between these systems here, but also to external sources like message brokers and other services. One of the key things to commission on the network is to look for redundancy between these and make sure that's correctly provisioned. And I'll show that later on in a future slide. Some of the outside interfaces that I alluded to earlier are message brokers and airport operations databases. When you check in at an airport, it looks, you'll be using a self-check-in kiosk like this, or perhaps talking to a human at a desk. But there's a lot that doesn't stay locally. Those messages go around the world and come back to the airport, and I'll go through kind of how that works. There's a system called the Airport Operations Database, AODB, and those are optimized for airport operations to manage the place. It includes pier schedules, status updates on bags, and other things, gate schedules as well. The baggage handling system interfaces with this to know where to sort bags. In addition, the baggage handling system will have its own backup pier schedules that should also be tested. At major international airports with large transfer systems, the AODB might also feed into forecasts for routing of bags, especially in tub systems. It's a very dynamic thing that would be modeled with differential equations on where, for example, tubs need to be so that bags can be placed on them. It's not just a one-way thing. You have to replenish stock as well. So you'll have to have forecasts for routing of bags. Testing of this system is integrated between all the stakeholders. I'll show you kind of how the messaging works now. So you check in at the self-check-in kiosk, and it prints off a bag tag for you and a boarding pass. That information all goes back to the airline's headquarters or their main data systems. From the airline data systems, messages get sent via messaging networks such as AirInc or SITA, which then interface with the local instance of the AODB, which is often from the same vendor. That then communicates with the baggage system upper level controls or higher level controls, and then we'll send the correct peer routing to the PLCs. The messages from the check-in to the airline and to the bag system are called BSMs, baggage source messages. As bags go through the system, they go under automatic tag readers, and then those will send the bag tag read to the PLC, to the upper level controls, and to the AODB through the messaging network and back to the airline. And those are called baggage process messages. Those ones let the airline know when the bag has hit different parts of the system and that it's on its way to the pier. This will allow airlines to know if there's bags that might miss the flight or if there's ones that have been pulled from the system for various reasons. I'll go over some of the key design features of the baggage handling system that you might encounter in the construction of an airport. First, the bag handling system starts with mechanical drawings. There are some general flow charts that might be produced before this, but the flows are pretty generally understood, so most designers will go directly to mechanical drawings, given that the airports are often built around constrained sites, the human flow, rather than optimizing for the baggage flow. If this was a factory, it'd be different, where you'd start with a process first and then build everything out from that. On these drawings, you'll see the general system orientation, implied functionality, and you can see some of the functions that are shown there, and access points. You'll see there's ladders, crossovers, catwalks, and platforms. Next, once mechanical drawings have proceeded to a pretty stable state, electrical drawings will start to be produced. There's drawings for device layouts that show where buttons and other panels are in the field, and also e-stop layouts showing where e-stop buttons and lanyards will be and which conveyors are controlled by them. The rules on how to do this will vary both by culture at the airport and by local codes and other requirements. In many places, you do not stop the whole thing from one e-stop because it's a very wide-ranging system. And if a guy at a pier e-stops because he wants to go for a coffee break, you don't want to shut down the entire place. In many cases, e-stops will stop the line that it's working on, so that if somebody's responding to an event and somebody's stuck in it, you'll hit the e-stop in that area to stop the system there. Other electrical drawings include panel drawings that show some of the devices that go into the electrical panels, or MCPs, and the wire numbers for the devices in each of the field devices. Once electrical drawings have proceeded a bit, mainly with the e-stop zoning, you can continue on to functional specifications. These are similar to what you'll see in base building HVAC systems or other things, but include other details like how bags are sorted and other security type rules. The functional specification includes the overall system functionality, subsystem functionality, requirements for any of the specialized devices, flowcharts on how things are connected, and the different process steps for how parts work, network requirements, network architecture. They'll list some of the devices that are out in the field. So it'll enumerate the number of HMI workstations or manual coding stations and ATRs and how many data drops might be needed at each. In addition, there'll be interface specifications for how they plan on connecting to different airline systems or messaging brokers. Now we'll go into some of the main commissioning steps. One of the highlights of a baggage handling project is a factory acceptance test. Often, these will use live PLCs with the actual code that will be running out in the field with emulated systems behind them. The baggage handling mechanical components will be entirely emulated with the correct length of conveyors. The system will send bags of varying sizes down. Also emulated are photo eyes and encoders, and they'll send pulses at the right speed and become blocked when the virtual bags pass over them. In the FAT, you can do very detailed I/O checks, so you can make sure that the PLCs or the port numbers used on the PLCs match what the intended function is. In the past, a lot of this I/O check was done in the field, but when you have many thousands of points, that can become very tiring, and also just because of the rote nature of it, the accuracy of that kind of commissioning goes down. Doing it in an office like this allows people to focus, take breaks for a bit, come back, and go through and ensure a high level of quality on those checks. In addition, since everything is completely under control, you can, for example, send a known number of bags down a system and then count the correct number of bags, or verify that the correct number of bags have shown on the upper level controls. This is repeated again later on in the field, but for large scale trials is much easier and cheaper to do at the FAT level. You'll check reports to make sure that the right number of bags have gone to each of their destinations. Once a system's been built, the controls engineers go out and start calibrating the system. The actual conveyors are slightly different than those that are emulated, and then they'll have to recalibrate some of the tracking parameters. Sometimes there's belt slip, or the tension might vary some of the different pulses per foot. They'll also confirm that the wiring matches the design. So as they go through and check each of the conveyors, if you flag the right photo eye and the correct conveyor starts, it'll be readily obvious that they've been wired correctly. In addition, some of the consultants will be going through and doing electrical and mechanical inspections, checking for the correct installation of mechanical equipment, and also looking that the wiring has been done in a professional manner. Site acceptance testing will look at major functions such as load balancing or other modes like generator modes or fire and life safety systems. Tag readers will be checked for read performance and correct tracking. Merges will be demonstrated, so bags will be sent down the main line and the merge line and make sure that and demonstrate that the correct merging works. In addition, fair merging, when you have one collector receiving bags from multiple places. You don't want the most upstream one taking up all of the slots, so the one airline might consume everyone else's space and then cause everybody to have to wait. You'll do throughput tests to see that the baggage handling system is going at the correct speed and can achieve the flow rates that were promised. Then there'll also be heavy volume tests that look to see how the system reacts in heavy volume cases. There might be unintended behaviors in start-stop scenarios or other cases where a jam downstream causes dieback behavior and hopefully doesn't that hopefully recovers correctly. You'll look at sortation, where fake flights will be created, bag tags printed for them, and seeing that those are sorted to the correct pier. The diverter function will be checked, the rates set each of the diverters, and also the accuracy of it. And finally, there'll be load and weight tests, or load test as in weight. Sometimes you use sandbags, which is not so great because if they break, you get sand in the bearings. Water jugs are an option, but water can be messy, or cut up rubber gym mats can be very heavy and easy to carry. You'll put those on the conveyors and look for the full load amps and the no load amps and note those down, make sure they match the specs. Security testing with security contractors or security agencies are a key part. They'll internal tests from the vendor, then pre-qualification, where the security agency will send somebody to witness some of the vendor's testing. Then there's qualification tests to make sure the system's ready for a full certification, and certification tests where each security function on each conveyor is verified. So this is bags being removed, bags being added, or sliding out of their tracking windows. Once the agencies have approved the system, there's change tracking that's required. So that any changes to those PLCs must be reported so that the agencies can check them if they choose to. There's integrated commissioning as part of this. So a lot of that baggage handling stuff might be invisible to you, but you may encounter some of these integrated tests as well. One is CCTV. The bag handling system has lots of stuff that can go wrong, and it's good to see what happened, especially when someone's bag is lost and they're quite angry on the other end. Cameras are often placed in drawings, but the drawings may not show all of the services that are in the way. In this one, for example, you'll see a duct that's over top of the system, but not shown on the drawings. Sometimes you'll put cameras out in the field and someone will put a duct right in the view because they're busy doing their part. So you'll want to check once everything's done that CCTV locations match what was intended in the design. There's generator power systems. So we talked about a little bit about this before. The steps that'll happen in some cases when the building goes into generator power, you'll be in normal operation. The generator starts and the baggage handling system stops. The B half, so half of the system, will start and flush all of the bags, and it'll stop. After that, the A half starts and can continue operating. It's often too expensive to size generators to run the entire building, so you might just go with half. Once normal power resumes, you'll want to make sure that the B half starts and enters normal operation. Other things that you'll see in generator power bumps is that devices will break. VFDs will burn out or photo eyes will just pop. They won't work anymore. So you'll want to make sure that those things are handled correctly and that they're enunciated correctly on the system. Network tests are important. You'll have redundant systems out in the field, but if various parts are, if they're cross-connected between the A and B halves, you can have a bad time. So in these kinds of tests, the network team will pull one of the switches or one of the other cards managing half of the system, and you'll want to make sure that messages still continue to go through the other system. Sometimes there's cases where the baggage handling will have one A and B mode, and then the network will have, for some parts, that swapped. So you pull one and you lose everything. You want to make sure that doesn't happen, and also that the failover between these systems works correctly. There's also total building integrated systems tests. So you're looking for unexpected failures of all kinds of systems. Often contractors will try to persuade you to not do these because, of course, it'll be right at the end of the job. But these are the most important ones because, see, these are the things that catch the mistakes that everyone has made. And the mistake isn't really in their own domain, it's in the interface with others. Um, and despite everyone's best efforts, they come up. In one case, I have seen a power monitoring server uh, being fed from the same feed that it's monitoring. So um, when that bus went dead, so did the server, and no subsystem knew what was going on. In addition, other things at an airport specific level, you want to make sure that the check-in desks, for example, that power that conveyor line behind it are also on the same bus. Now, if they're on the opposite side of the hall, that's going to be very inconvenient. That's the overall view of it. If there's any questions, type them into the question and answer box, and I'm happy to go through them.
Thank you, Eric. We do have a question that came through the chat. I don't know if you see it here, but it says, how does integrated site acceptance testing differ between US and Canada airports?
Okay. So for at the security level, security testing, I think, they're very similar. The different agencies have different, they do have different security rules. American airports do tend to send more bags to search than Canadian ones. So that's a sort of philosophical change. So some of the rules are different, and so we'll be checking those. But the general process is about the same. There's the vendor's internal tests, and nowadays, since we've done a lot of since all the vendors have done a lot of these tests, they frequently do pass them without any trouble. So pre-qualification will happen. For example, the agency will send folks to visit the contractor's own internal tests. Qualification might be 1 or 2 weeks. Certification, again, another 2 weeks. They usually budget for 4 to cover everything. And in case the vendor's done an awful job and there's some work to do, but it's about the same between Canada and the US.
Okay, and here's another one. Are airports seeing a greater need for third-party commissioning of BHS similar to building systems versus the BHS designer acting as the owner's rep doing commissioning?
It can depend. I myself have been the commissioning authority for my clients, and different than um, the BHS consultant. I see value in it, mainly because I'm an airport guy. That's kind of what I do. So I see a lot of the interfaces with the other systems, understand what operations wants. So a lot of the lower level stuff, mechanical and electrical checks, are totally fine to have in the domain of the BHS consultant. But then some of the more higher level functions, and especially the integrated ones, are good to go with a third party person who sort of knows how all the different players work and can sort of speak to that.
Great. And then it looks like we have a question through the Q&A. How do you manage the paperwork side of commissioning and functional testing? It seems intensive and likely some custom software is used.
Yeah, that's a good question. Most baggage handling systems are kind of bespoke. They're a bit like a suit. You could have ones just off the shelf, and those would be a little easier to do. But each airport has their own needs and desires and shapes, and so one size fits all doesn't often work. Doesn't work so well. Also, just because of the variability between the systems, and also how different parts evolve, most of the commissioning is tracked, unfortunately, with Excel or other ad hoc things. You could develop your own software for it to track some of the stuff, but you know, if you were a large firm doing many places, you might do that, but there aren't software packages to do that. And even then, in those cases, the software packages might not match the workflows that people are doing out in the field. So yeah, it's a bit ad hoc, which can be a bit a lot of work sometimes.
Okay, it looks like we have one more question. Do mobile inspection tables increase or decrease the overall testing and commissioning process?
Oh, that's a very good question. Yeah, new baggage handling systems use or may use mobile inspection tables. So in the past, the search area had a lot of queue conveyors, and those were all part of the baggage contractor scope. Nowadays, there's mobile inspection tables, which may be the same baggage contractor you have, or a separate one who's providing them. Um, you're not testing each individual table now for functionality. So there's fewer line tests to do. So you're not testing as many queue conveyors out in the field. So in that case, it does. I think it can speed things up. But on the whole, I wouldn't so much count on it reducing your windows, because you'll have additional testing to do between the MITs and the base building and the base baggage handling system. That won't be part of the security testing, but that could push out some of the things, especially if it's different contractors doing those parts.
It looks like I got one more question.
Yeah.
How has the pandemic impacted commissioning of airport baggage systems? Are new tools being used to address the challenges?
Yeah, I had to witness test some of the integrated functions remotely. So I I don't know, help build an airport from my couch, I guess. So that was a bit funny. But to be honest, it was actually not so bad. I had access via VPN to the HMI and the reporting systems, and the upper level controls we had was extremely good and allowed me to pull all the reports right from my home. And in one way, being blind in one way forces you to be more perceptive in others. So as long as there still is somebody out in the field taking a look what's happening there, that constraint can actually give you insights into other parts. So that was surprising, but also effective. And another controls engineer friend of mine happened to commission an AI hopper sorting algorithm, the first of its kind, and had to do that remotely. And so what they had used was Microsoft HoloLens. So that's the heads-up display thing, and a field engineer on one side, a more junior person, and then the senior guy was overseas and watching remotely at 2 a.m. as they did the work.
Well, that looks like that's all the questions, Eric. We really appreciate your time and expertise today.
Mm-hmm.
Just as a reminder to everyone out there, if you haven't already done so, don't forget to renew your membership so you can continue to receive these informational tech talks and other valuable benefits that the BCA offers. And the password for this tech talk is changing and will be sent out to you along with the presentation in a few days. So on behalf of the BCA, we'd like to thank everyone for your participation in today's Tech Talk, and have a great day. Thank you again, Eric.
Thank you. Thank you, man. Thanks for having me.